Today, I'm going to take you through a brief introduction of who we are and what our product does. And I'll show also a small demo just to give it a bit more hands-on feeling. Right, so who are we? We are based in Ghent, here in Belgium. We exist now for about 5 years, and we are very much a product house focusing on what we believe is the best automation and time series analytics platform for IoT. We are, as I said, fully focused on developing the platform. It is not really focused on one particular IoT domain. And as you will see in some of our customer examples, we have customers using it in quite a number of different areas and for a number of different use cases and business cases. All right, so this is an example of a customer in Germany that is using Waylay for monitoring industrial equipment. What you need to know is that this customer is basically leasing industrial equipment like compressors to their customers. And as part of their support contract, it requires them to proactively monitor the performance of these compressors. So what basically Waylay does is it processes the data coming from the sensors, vibrations, temperature, rotation, whatever, and then checks those values against the SLA that the end customer has with our customer, right? And if the engine is underperforming, certain KPIs are not meeting the SLA requirements, then basically actions are taken. That could be that a field engineer is dispatched on site with the right spare parts to fix the problem, or it could be that an automatic recalibration of the compressor is done, or a reset is done, and so forth. So ultimately, to basically implement the business logic that is behind the processing of that raw sensor data, that's where Waylay comes into play, right? So this customer of ours is basically implementing a set of business logic that runs on the Waylay platform to process that data and then, of course, visualize those results to their customers with a dashboard and ultimately also do an integration with, for example, a Zendesk help desk system when things go wrong. Another use case is a use case in Australia, where a customer of ours is using Waylay to optimize the energy consumption of public buildings. So what you need to know about these public buildings is that these buildings contain a large set of heaters, boilers, chillers, HVAC systems from many different vendors. Okay? And they're using our platform to pull log files from these machines, process those log files, and basically calculate optimal set points such that the energy consumption of all of these multi-vendor devices is minimized while still maintaining a good air quality within the public building for the visitors. Okay, so they have implemented a number of rules on the Waylay platform that look like this, that are basically processing the raw data and calculating optimal set points. This customer is using Waylay in a completely headless way, meaning that log files are uploaded, Waylay produces recommendations, and then the results are basically forwarded to a visualization tool. In this case, this customer was using Tableau. Okay, and as you can see on the bottom of the screen, they've been able to generate quite some savings. This is actually coming from a public report at the end of last year, so we're kind of proud of that. Just to give you an idea on the volume of traffic that this customer is sending to Waylay, this is a customer that is generating 1 billion transactions per month on our platform. So it's one of our largest deployments that we have. Another use case for Waylay is another type of market that we address, and then we specifically focusing on connected appliance vendors. We have a number of customers in the US that are using Waylay as a tool to process information, error codes, log files, raw data coming from connected fridges, connected ovens, and what have you. Okay, and this is more in the context of customer support. So they're trying to do proactive care around the data that is coming from these fridges, such that when the customer calls the help desk, that the root cause analysis is already performed by Waylay, and that a recommendation is shown to the help desk agent, for example, in Salesforce, to take action. So in this case, like I was saying, this customer is using Waylay in a little bit of a different way than the other customers. So this is more for customer support use cases. So as you can see from the other use cases, that they're active in almost all different domains. But what they share in common is that there's quite a number of data coming from their assets that are in the field, and their existing IT systems, including alarm management systems, CRM systems, and what have you, are obviously not suited to deal with that amount of data and the type of data. And so typically what you have is that the data is very raw. It needs to be processed before it can be used within the IT systems. And that's typically how Waylay can definitely help. Maybe a last customer case. This one is actually mentioned on our website, and I encourage everybody to basically have a look at the Conrad Connect website. It's a bit of a completely different use case in the sense that it's not B2B but B2C. So Conrad Connect is using the Waylay platform underneath their solution to offer end customers, so end users, the ability to program and control their smart home with appliances from many different vendors. So they have a quite extensive ecosystem of smart home appliance vendors, like for example, Netatmo, Philips Hue, and so forth. They basically hook up to our platform, and then the end user has an interface through which he can set up rules that allows them to for example, basically turn off all the lights when you leave the house. And this is a typical recipe that they offer as part of their IoT projects, and that you can actually share that across different users as well. So we are the engine underneath Conrad Connect, and we're actually quite proud of that. We have different modules. At the core, at the heart of our offering is, of course, the automation engine. That's where it all started. But in the meantime, we have created a bunch of additional modules. We have time series analytics, for which we actually have a quite detailed webinar explaining what it does. We also have a B2B dashboard. It's also important to know because we have some customers who basically want to go to market quite fast, and they have a number of limited use cases that involves visualizing a set of KPIs to their end customers. Okay, so for these customers, we have the ability to offer a dashboard that can visualize, like I said, KPIs. You can create your own widgets to show a dashboard to your end customers. And some customers do not take this, and they integrate it with their existing UI or completely use Waylay in a headless way. Hope that's possible. In terms of our technology, everything is REST API exposed. So it's quite easy to integrate that with existing IT systems or ERP systems that you may already have. From a licensing point of view, it's always a volume-based or a usage-based licensing scheme that we have. If you're interested, please contact me. It's basically a tiered model. So that's from a high-level point of view, the way that we go to market. So what you see here in the blue parts is what we offer as part of our solution. So as you can see, at the heart of the solution is the Waylay automation engine. This is an engine that is patented and is partly closed source and partly open source, in the sense that your business rules are basically running on a Bayesian inference model engine that's implemented on Scala. That is the closed source part, in the sense that we don't open up the underlying engine, but of course you have a UI through which you can create your rules. But on the other hand, if your rules are making calls to process data, transform data, or make API calls towards external systems, this is executed in a sandbox cloud function environment. Basically, they are JavaScript functions that we execute, and that is open source. So we come with our platform with a large library of nodes that you can drag and drop inside your rules to process specific data or to make API calls towards, for example, Salesforce. Well, all of this code is open. You can change that. You can take it as is, or you can add your own as you see fit. On the left-hand side, we have quite a number of connectors towards the most common B2B IoT platforms. We have integrations with the AWS, Azure, Google IoT Core, MQTT brokers. We even offer our own MQTT broker in case you don't have one. But if you're a fan of MQTT, you can definitely use ours if you want to. You can also integrate with yours. We have integrations with LoRa and Sigfox backend, narrowband IoT, and so forth. Okay, so it's pretty straightforward to connect with those, and most of them are completely in a self-service way, so you don't need any involvement from our DevOps team to be able to set it up. At the bottom, as soon as data comes in, on one hand we shoot it through the rule engine, but we also store the data in a time series database. And that time series database is then used for time series analytics. So then we're talking about soft sensors and soft actuators that act upon, for example, anomalies that are detected or predictions that are made based on a data modeling that you can do within the time series analytics module. And then on top, in terms of UI, we of course have our developer UI, and that is by default enabled. And that allows you to kind of program onto the Waylay platform. But we also have like I said, a B2B dashboard that is more towards the customers of your customer to visualize some statistics, KPIs, and what have you, and create a dashboard for visualization of what is going on, including creating alarms, for example, and then sending emails or SMSs to the people that need to act upon it. So it's kind of a simplification, a simplified view on top of the automation engine. And yeah, for some customers it's enough. Other customers want a little bit more complicated rules, let's say, and then of course you need to go into the engine yourself. So let me now give you a small demo of the Waylay product. So I'm going to log in to our demo platform as a developer. So this is the UI that you would see when you log in and you want to basically create business logic, or you want to connect devices and data sources to your platform. The first one that I wanted to show is the concept of resources. So resources are basically sources of data that you can use within your business logic. That can be sensors that are actually streaming data to the platform, or it can be sensors that you have to pull, but it can even be, for example, IT systems, like an inventory system that has inventory data that you want to use into your business logic. So for us, it's also a resource. So I have hooked up a number of resources here, but I'm just going to pick one. I have a connected oven connected to our platform. When I go and click that resource, I see a set of metadata available, including the metrics that it sends. So that's basically the data that it sends, who this device belongs to, etc., etc. You can also have a look at the data that is coming in. This is, for example, the data in real time that is being posted to our environment, and you can basically follow that data in real time and troubleshoot it. You can also have a look at what data is in the time series database. So here, for example, I'm going into the TSA, time series analytics module, just to see, okay, what data is coming in. This is, for example, fan rotation speed coming in from the last couple of minutes. Can then zoom in and out as you see fit. Okay. This is also the UI through which you are going to be able to create models for anomaly detection and prediction. that you can then use within your rules to further basically take action when an anomaly is detected. Once we have data coming into our platform, you're going to use that data to do something. Okay, so in order to express your business logic, you can use the rule designer. But for this use case, I've already created a rule. So let's take the rule for our connected oven. So here we have basically our rule. So this is, I'm now in the rule designer. And here you basically see, let me zoom out here a little bit, a full set of example logic that you can drag and drop onto this canvas to express your business logic. And so here is where the oven data is coming in for the rotation of the fan. And we're basically going to compare it to a threshold. And then, whether it's above or below a certain value, we're going to take action. Okay. So I'm going to focus here right now on the latter part of what happens when, for example, the rotation of the fan is below the expected value. Well, in that case, we're going to do a number of things. We're going to generate alarms within the Waylay platform, but we're also going to take action towards the Salesforce customer care system. So when the speed falls below a certain threshold, we're going to look up the asset in Salesforce and then create a customer care case that this oven needs some maintenance. Okay, so it's a quite simple use case. As I mentioned before, all of these nodes are basically executing cloud functions. Okay, so if you want to know what this node, for example, does, well, you can actually look at the JavaScript code that powers it. And this is basically what this node does. It looks up a particular name, in our case, oven, and it's going to check within Salesforce whether this asset can be found in the Salesforce asset database. Okay, and then it returns a state, found or not found, and raw data, what comes back. So easy to update, easy to change, easy to enhance as you see fit. Okay. So we have a large panel of available nodes that you can drag and drop onto your canvas. So if you don't want to write any Java code or JavaScript code, then you don't really need to. There's quite a large set of soft sensors, gates, actuators available that can do all sorts of things. Okay. So let's now say we've created this template. We can now apply it to a set of devices. And for example, here, if you go to tasks, you can actually see on our platform which tasks are currently running and are basically processing live data from sensors. So let's get back to our oven use case. This is, for example, the task that is currently running and where data is basically flowing in. So here you actually see, for example, the fan rotation speed. It's very nice and very stable. We have temperature values also coming in. And we also have a sensor in the oven that basically checks whether the door is open or not. So if I open the door here, for example, and then you see here the state of these nodes changing live, right? And you can basically evaluate how this logic is going, okay? So for example, if I focus on the fan rotation speed now, and let's say I block something in the oven to reduce the speed, I've actually stopped it here. You basically see really live what is going on with our connected oven. You see it dropping to 0. Now it's back to a normal state. Okay. So if this happens quite often, it's clearly a sign that something is blocking. It could be dust. It could be somebody left a sweater, for example, and that is blocking the fan, and it's potentially a hazardous situation. So as I mentioned, as part of our rule, we're basically going to trigger a case within Salesforce. So if I now go into Salesforce, so here, for example, you see that a case has been created that basically says, hey, necessary that somebody comes along to do cleaning. So this is kind of a proactive case that we created on the asset oven, and the description is schedule cleaning for this oven because it's potentially a dangerous situation. And then you can also from Salesforce execute a rule back into Waylay if you, for example, want to evaluate the historical data that was received. Okay. Right. So what else is there onto the platform? Well, alarms, as I mentioned, alarm management is one of the advanced features of our platform. So here you have a complete view of all the alarms that are currently open, their severity, and so forth. You can actually change the status of alarms, active, acknowledged, or cleared. You can do that completely programmatically as well. So here you see, for example, in this case, we are monitoring an asset, a critical asset with low connectivity. Here we're monitoring the signal strength of our a wireless sensor that is connected to this device, and we have basically a rule that generates a recommended action, which is to basically reposition the antenna, for example. Okay. One other nice capability is once you start creating rules, you want to test rules, right? And we have the ability to do simulation testing, where we can, for example, test a template that you created before with for a particular resource, and then send a single measurement into your rule, or even do a template batch run, where we, for example, can run the rule against pre-recorded data. Okay. One thing before we move on to the Q&A section is to maybe show briefly what our time series analytics can do. So if I take a nice example of a turbine, so this is, for example, the rotation speed of a turbine that is in the field. So obviously a turbine is supposed to rotate pretty stable around a particular number of rotations per minute. Okay, so with the time series analytics designer, you can basically start building algorithms in a very easy way and instantiate them immediately to be able to use them within rules to take actions. So what you have to do is you basically select your data set that you consider as the normal behavior of your sensor. So this is the data that is coming back from the turbine that I consider now as kind of the normal behavior. Okay, it's fluctuating around an average of 600 rotations per minute. But I don't really want to set the sigma squares myself. I just want to let the system figure out what is the best model to kind of model this normal behavior. So I just click auto configure. So the system is going to do some analysis on the data set. It's going to profile the data. Okay, I'm not really interested in seasonality, although it's found some seasonality, but I'm more interested in, hey, I want to apply a fixed model, and let's use that now. So the system is now going to generate a fixed model that will allow some deviations from an average value here. And if I now apply that model against this data set, where clearly you see a large deviation from the normal, it's basically going to tag all of these data points as anomalous. So here we basically calculated all the anomalies across this data set. So let's say I'm now happy with my configuration. I can save that. So rotation Tom, for example, that already exists. So rotation Miruna. So I'll save that now. And once it is saved, the system is basically ready to power it in an anomaly sensor. So one of the sensors that you have available here in your library is an anomaly sensor that is now already automatically configured to use the model, the algorithm that we just defined in TSA. Here it says rotation Miruna, and now we can basically assign a particular rule. Let's keep it simple and basically say we're going to assign Twilio SMS whenever this guy moves from into anomaly state. Okay, so if this guy goes from no anomaly to anomaly, well, then I'm basically gonna send a message, anomaly detected, and then I can send it to a particular SMS number, right, etc. So you can now instantiate this rule and apply it to a number of different devices. So it's that easy to kind of create these kind of rules. All right, so we touched upon a number of different things. I know I went quite fast, but yeah, the key takeaways that I would like to focus on is that the team here has been quite active within the domain of both IoT and telecommunications for many years. And we know how to build software. We know how to build enterprise software with high availability guarantees. And we know what is really needed in an enterprise context with respect to upgradability, monitorability, and so forth. So we are applying that knowledge now in the IoT domain. And we think we have a platform that has no match in the industry today.